Negative 1,000. Positive 1,000, so 0, negative 1,000. I think I'm splitting hairs at this point because there's more lash in the screw than there is accuracy in what I'm doing or need for. Zeros. 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 It's close enough for me. Okay. Tool offsets. Calibrate X, calibrate Y, exit. First tool. Okay. So what we're doing here, if there's anybody out there watching, is we're gonna, 1 second. We're taking this Rubitracks hub, heavy duty hub, and we're gonna drill a 10-hole pattern in it. And it makes sense in a minute, but basically it's gonna have your standard, you know, 8-hole, like you know, like a 3/4 ton truck will have, but we're gonna put another hole, sort of like what we got here, right? We got our 2 close studs, our 2 far studs, and our 2 close studs. So now he'll be able to bolt these tracks onto anything, theoretically, with 4 studs, 5 studs, 6 studs, and 8 studs. So we'll get this thing all set up, get our tools set. I've already done the programming in the mill, which was minimal. I just had to modify an existing program, but what we have to do now is select and set our tools. So mill is pretty dirty. Working like 16 hours a day here right now and just don't have time to clean it, but it'll get cleaned eventually. Now I've got a little locator pin that is either in here, or if I was smart, I probably put it back in my toolbox, but I'm not always smart. Let's go check in the toolbox. So while we're at it, this is our Rubitracks mountain. This is what we're kind of making the hub for. This is the standard hub for the 6,500 pounds, but we got one more set over there that takes these hubs, and you can see the pattern right here. We got a regular 8-hole pattern, but then we've got 2 extra holes right here, and that'll allow us to switch between bolt pattern adapters. This is a typical 6-hole adapter, right? So if we if you can imagine, if we were using it in this pattern, these would line up here. This is a different diameter, of course, so it doesn't make sense, but then we would choose, if we were doing 8 holes, we'd use this stud, but if we're doing 6 holes, we'd only use that stud. So I'll have more info on a future live stream, I'm sure.
Break it down into its constituent pieces. You want to do 20 analysis, figure out what the critical few are, and put them in a logical sequence.
For now, we just got to get those suckers drilled so I can go home and sleep, so that I can get back here tomorrow. This is a little locator pin that I use to index the hub. So you see I've got an indexing hole right here on the hub, and that way I know I don't, when I come to drill, I don't actually drill through my screw holes. Anyway, it all makes sense to me. I don't know if it's making sense to you, but we'll talk our way through it. Okay. So that just keeps it in the right place. Now I need to set up my tools. So the first thing we need is a 5/8 drill, but we need a longer one than that. I could have probably had them set up prior to turning on the live feed, but oh well, oh well. Doesn't bother me any. Okay. My long 5/8 drill. Is that the one I want to use, or is this the one I want to use? Let's just go and give this a kiss on the grinder.
That grouping of some more chaotic conditions, which is very exciting. So I'm interested in any tools that are off the beaten path that seem to raise interesting questions that have not been answered in a satisfying way yet in medicine. And I think we're still largely in the dark ages with respect to psychiatry.
Oh, I think the best psychiatrist would agree with you.
Yeah, and the best psychiatrists and the best scientists and the best fill in the blank are acutely aware of the limitations of our current methods and the limitations of our current knowledge. So I think the mark of a good thinker, the mark of a good scientist, the mark of a good fill in the blank anything is someone who says, I have no idea, or we have a lot.
And hopefully they also say, look, still figure it out.
So, first thing we got to do is set our tool length, and we'll do that with a piece of paper. Right here. That will get me within a couple thousandths of surface, which is well within reason for drilling. Okay, so our diameter is going to be 0.625, and then we'll calibrate our Z. Now we're on to tool number 2. The whole air compressor pounding away again. We got a new one coming, supposed to be a little bit quieter, probably not a whole lot. Two, and then our countersink. A little thicker paper for this one because I modified the bottom of the tool. So. And that's 1 inch. Calibrate the exit. Okay, I think that's our tools set up. We'll be ready to drill here. Chicken Louie.
Could be a concentration package with 20 minutes of sitting.
I think that's sharp enough. Okay, we'll get some of our things out of the way here. I'll have this thing with me. If anybody has any questions, probably be on here for a couple hours. Maybe not, maybe an hour. But I'll check in on it every now and then, and anybody's got any questions, we'll see if I can answer them. Okay. Now, before we do anything, we want to draw the program and just make sure that it's going to do what we want it to do. Okay. Now view, let's look at it from the top. Okay. So before I go and jam a tool in it and ruin $250 worth of aluminum, let's just run a empty holder and select exit auto and just kind of prove the program. So we want to be an M41 right up here, high range, which we are. Okay. So it's going to drill this hole and then probably this hole, and then it'll do the 8-hole pattern. The reason it's doing that is the way I programmed it, these 2 holes are individually programmed, and then the other ones are part of a 8-hole bolt circle. So rather than having to put in 8 more hole locations, I can just tell it to do a radial path and X amount of holes. So there, now it's doing the first hole at 22.5 degrees off of our x-axis. What's our feed rate? Ten inches a minute, 1250 RPM. And I bet you I can speed that up. So let's go on Little Machine Shop. Little Machine Shop speeds and feeds. Nice little calculator. So we're milling, we're drilling. Materials aluminum, we're using high-speed steel. Cutting speed, it says is 250. Drill diameter 0.625. Machine max is like 3,000. I don't think it matters. And calculate. So it's telling me that can't be right. Drilling aluminum, 300 RPM. That can't be right. Right now it's 1250. Drilling aluminum with a 5/8 drill is like, what is going on? This is not right. 2 cutting edges, max machine speed is 300, 3,000. That's better now. 1,530 RPM and 20 inches a minute. So right now we're at 1250 RPM and 10 inches a minute. So we're gonna go up to 1515 inches a minute here in a second. So I'm happy with that right now. That just did a cycle. We know all our holes in the right place. So let's go manual and let's edit this. So hopefully you can see what's going on. So let's go up and let's go 1500 RPM and feed rate. Let's change that to 15. So we'll be a little bit conservative, but we'll get home sooner. Insert 15.0. Okay. So that gives us our 2 holes plus our radio pattern. Now, T2 is 1.125". Let's see what they want us to run an 1.125" drill at. Drill diameter will be 1.125. All the other information stays the same. 850 RPM. We got it at 600. Let's turn it to 850. Let's turn it to 800. I never like to go right up against the wall. So S800. And then the feed rate, they're saying 18 inches a minute. So we're gonna go for, Jesus, 18 inches a minute. Let's go 14. .0. Okay, and the last one we'll just leave alone. That's just our countersinking tool. I'm happy with the way that thing runs normally. Exit. Now, edit. Exit. Program. Draw. Run. View. XY. Booking. Okay. Exit. Select. Exit. Auto. And let's go for another dry run here. There, she's singing now. That should remove some material. And then it's, like I said, it's doing this hole first, then this hole, and then it'll do the 8 holes. I'll stop it here right as soon as I get a chance. I just want to verify everything. I think we're going to stay in M41. We're going to stay in high range the whole time. I'll have to check the program. I think 600 is M41 200 and higher. M40 is 50 to 500. So I think I was already set to be in high range for the big drill. I think the big drill is going to be like crazy noisy. Alright, let's stop the program, spindle off, manual, turn the coolant pump off, M9, coolant pump is off. Alright, let's take a look at this program. So M41 high range for tool 1, tool 2 doesn't change, so it stays in high range. Tool 3 is 300, but it can stay in high range because our high range will run 300. We'll run down to 200. So we're staying in high range for the whole job. Good. One less thing to mix up. Okay. Manual Z. This is always the scariest part. Always the scariest part. Okay, auto. Point the coolant at the drill and hope for the best. Definitely making chips. And we're high enough to clear. That's a good sign. Oh, come on. Okay, I have to let it get out and stop it here in a second. Okay, spindle off. I need 2 coolant lines. Okay. Turn the coolant back on. And spindle forward. And run the program. All right. Better put my safety glasses on. Shit flying everywhere. Now normally this would make me nervous because my jaw's there, but I did clearance the jaw, and I know I did an 8-hole pattern before. Yeah, and it didn't hit anything. So we're drilling 8 on 170. So that's basically Ford bolt pattern, Super Duty bolt pattern. One more hole and then we'll change the tool. Oh yeah, she hit her there. Did we ruin the drill? It definitely hit. It definitely hit. Just barely kissed the edge of the drill. I would say I'm going to have to clearance that jaw before I do another hub. I'm okay with the big drill. Now it doesn't go through, this one goes through 200 thousandths. So it obviously just kissed the edge of that fucking jaw. And I can feel it too, so. Okay, that's not a big deal. I'll sharpen that. Doesn't look like it really hurt it. But you could hear the noise. I could hear the noise anyway. All right, drill number 2. The big one, and this is going to be noisy. I know it. 800 RPM. Hand on the E-stop button. Removing material though. Turn our feed rate up. What if we turn? Right now I'm at 640. I just turned the spindle speed down. Yeah, I think that's... The drill is really too long for what we're trying to do here. So it's making a lot of noise and it's putting some chatter in the bottom of the hole. Which isn't gonna matter, because we're where the lug nut seats, it will, yeah, slowing it down was the right thing. Where the drill, anyway, where the lug nut seats will, the countersink tool makes the seat nice and smooth. So, I should blow this out. Where's my blow gun? Right here. So you can kind of see maybe the facets down in that hole, and that's just the noise from the drill now when I slowed it down. But you know, anyway, I'd almost like to do another pass at a much slower speed, but we are going to slow it down on the next part. But anyway, that doesn't matter. It doesn't hurt a thing. This tool cleans everything up. Basically all this big hole is just to make room for the socket that goes over the lug nut, and then the lug nut will seat on this chamfer that this chamfer tool is making. it. There, you can see the holes now. You can see that nice seat that that tool just made. And that's it. That's one hub drilled. Got 3 more to go. But before we do, I think we're going to have to clearance right here, because I'm confident that's where I think the drill hit there when we were drilling that hole. So the way we're going to do that is we're just going to put a carbide end mill in the milling machine and feed it in with the dongle.
That's the best phrase, but I can't think of any better one. If you can think of a better one, please.
And my carbide end mill is right here.
How do I think about mine allocation or potential allocation?
So we'll go to manual, we'll go to S500, we're not in a hurry. Enter, and spindle forward. And then we'll just drive her in here. Don't try this at home, kids. I should actually. I don't know if that jaw is going to dance around. I should be squeezing something with it. Don't want to take too much off because I need that shelf to for the part to sit on. But I've got one shelf here. Okay, I think that's good. So So we'll just drive right over to the other side and we'll clearance the other one too, because they're on the same diameter. When I clearanced these last time, it was for 8 on 6.5 full pattern. So now that we're doing 8 on 170. We need just a little bit more room. This should make a real machinist cry, I bet you. I almost wish that there was more than 3 people watching the live stream just so I could stop and read the comments. So there, that's handled. And spindle off. Okay. So there you can see the hub with their regular 8-hole pattern and then the 2 bonus holes for the Rubitracks pattern. Okay, let's pull a couple more hubs out of here. I got no room. I'd like to bring this cart right over to the mill, but as you can see, we're assembling tracks. These are the Rubitracks Mountain. We're building pallets. There's the pallet station. We got plate on the floor so that we can cut with the plasma table. We got the drill there so we can tap bushings. Like, it's crazy here. It's a zoo. It's a zoo. I don't mind. So we'll line up our locating hole with the pin. And just make sure it's in there good. Tighten her down, nice and tight. Pull that out. And start with our 5/8 drill again. I'm going to run this on the grinder just to be sure that that little collision didn't.
And there are a lot of forces at play online that want to manipulate or shape your behavior in different ways. So I feel like it is imperative for me to cultivate the ability to just sit still and not consume the 5 minutes in line waiting to get into a restaurant by having activity. So that's part of the reason. Could you tell us about Cock Punch? Yeah, I can tell you about Cock Punch. So Cock Punch is a creative project intended once again to make me less precious about protecting whatever brand I think I might have. And this is an investment in my long-term mental health also, and I think in my creative ability, my willingness to experiment. Cock Punch could be a long story.
Okay. Let's try hole number 2. Or not hole number 2, but part number 2. See how long it takes to drill it. So I think we need to be right about there, but we're gonna go in here and edit our program for speed on the first drill. So we had it set for 1500. I don't No, that drill was all right. It's the second drill. The second drill I didn't like. S800. We're going to turn it back to S600. I think if I had a properly sharpened drill and maybe a little bit shorter, it would make a nice cleaner hole. We're just going to take our feed rate and turn it to 10 inches a minute. Okay. Exit. Auto. And we should be good to press the green button. 1. Okay, let's check for sure. But our feed was ahead. Spindles on 100%, feeds on 100%. Green button, go. Definitely poking a hole. Down closer to the bottom now. I swear if I had two. And there is a spot for a coolant line, but it's only connected inside. I got to pull the front out and run a T and a hose over to the second line. But then I could point, and then it wouldn't matter if one was missing because one would be getting it. But tomorrow we'll put these in the oven and put the raceways in, and then they'll be ready to finish turn on the lathe just to get that nice clean up cut on them. Man, we're close to the hole there too when we get through. Like that drill is none too long. I'll have to remember that next time that I need to leave enough drill sticking out. Like we got, yeah, no extra room. Why is that? And this hole is where it collided with the jaw on the last part. So we'll be able to hear it if it does it again. No, no collision. Okay. Now we'll see how it likes the big drill. Now we're at 600 RPM. Definitely a cleaner hole. Not as clean as it could be. Probably could peck a little longer too. So you can hear those surges. Basically what that drill is doing is it's going down, taking a bite, coming up to release that chip. So every time it makes that loud noise, it's peeling out a chip like that, and then it's coming off a little bit. Basically to break that chip and get it out of the hole so that it can start and make a fresh new chip. If it didn't do that, that chip would just continue to wind around the drill and would have a big nest. Also, if we were doing a deep hole, it would pack into the flutes of the drill and just kind of burn and turn. That's 2. Still a noisy hole. I don't know if you can see the facets in it. Try and get up close there. They don't matter, it's just they don't look as good. What did I do? Right here. They don't matter because that's the only surface that matters, is what this tool creates. All that big drill does is makes a little bit of clearance. My coolant needs changing too. It's a good thing we don't have smell-o-vision on here because it smells like ours. So that's it, totally elapsed time, 6 minutes and 51 seconds of machine on time to make this part. Obviously that doesn't take into account the time it takes to, you know, change the tools and change the parts. That's just basically the amount of time it's spent with the machine in go. So you can see our hole pattern now. So we got our regular 8 on 170 bolt pattern with our 2 bonus holes that allows us to build a Rubitracks pattern. So this will take 4 stud, 5 stud, 6 stud, and 8 stud. I don't think we could do a 7. I've never tried, but I think a 7 will interfere. But there was only one truck in the history of trucks that I'm aware of that had a 7-stud hole and it was a piece of junk. So hopefully nobody ever calls looking for a set of tracks for a 7-stud Ford. Okay. We'll run in again with our 5/8. That's crazy how close that collet is getting to the top of that part. I almost wonder if the drill didn't slip in the holder. Because I used that drill like... I used that drill for a taller hub, for a 6-inch tall hub. This is only a 5 and 130, or at least it's supposed to be a 5 and 130. Yeah, that's crazy. Don't know why that is. Anyway, problem that doesn't need to be solved tonight. There, that seems to be the magic speed, 540. Maybe not so magic, still noisy. Slow it down just a little bit more. That's making a nicer hole. And our countersinking tool is here. All right, folks, that's it. I'm going to spare you the details.